from the beginning of this course, we've been looking at integration and techniques of integration. We're going to kind of step away from that for a little bit at least, and we're going to start taking a look at another part of the course where we're going to start taking a look at sequences and infinite sequences, which are going to lead us to the idea of infinite series. And sequences are kind of the foundational building block as to what an infinite series is going to be built upon. And so in this section, we're going to try to do three things. So first of all, we're going to define what a sequence is and just produce some terms in a sequence. Then we're going to figure out what an infinite sequence is. And then we're going to be able to find the limit of a sequence, both geometrically from a graph and then analytically by using methods from calculus. So let's start by defining what a sequence is. Sequence is just going to be an ordered list of numbers, okay, or other elements like geometric objects that have to follow some sort of pattern. So if we look at this sequence 4, 9, 14, 19, 24, we can clearly see that each number, we're just adding 5 to be able to get to the next number or each of the elements in the array. So there's different ways to be able to express the sequence. And one way to think of it is, like I said, as an array, to where we have an element and we have a term that's kind of affixed to that element. So the first element would be 4. The second element would be 9, the third element 14, etc. The fourth element 19, the fifth element 24. And of course, this goes on infinitesimally. All right, so this would just keep following the pattern as sequences do. And one way to be able to express a sequence is in its explicit form, where if we substituted a number like 3 back in, we could get to 14 immediately. So we wouldn't have to just keep adding 5 and add 5 and add 5. And for instance, we want to figure out what the 15th term in the sequence is. One way to do this, for this particular example, is to just represent n as the index. So n right here is going to be the term within the sequence. And to be able to get to the actual number or the value that holds the place of that index, we would just substitute the value 1, 2, 3, 4, 5 back in for n. And that would give us the output. So it's basically like a function. So for instance, if we plugged in 3 into n right here in this 5n minus 1, that would give us 14. And so if we wanted to list out the first few terms of the sequence, we would substitute 1, 2, 3, 4, 5. All right, so it's really easy to be able to evaluate the terms in a sequence. What's not so easy, though, is to come up with these explicit forms. In this course, we're not going to look at ones that are too difficult, but in another course, such as like, something like discrete structures or something like abstract math or something like that, then you might have to come up with your own sequences. All right, but these will be pretty easy. They'll be pretty self-explanatory. So infinite sequences can be defined in a number of ways. And so one way is just to write out the terms in set notation. So like 4, 9, 14, 19, 24, etc. And then ... meaning that follows an infinitesimal pattern. A sub n, which is the name of the sequence, and n is going to be basically what your independent variable is, or the index, is going to be equal to 5n minus 1, where n is greater than or equal to 1. Or another way to write an infinite sequence is like this. Okay, so a sub n, and then we have brackets infinity n equals 1. All right, so this is the lower bound, n equals 1. And this is the upper bound where n is equal to infinity. Okay, so this is the lower bound and this is the upper bound. Almost similar to integration, where we have the lower limit and the upper limit of integration. So let's just take a look at a really, really basic example of how to work with a sequence. And one thing that we're going to do is we're just going to write out the first 4 terms of the sequence. And then I'm also going to plot the terms. And I'm going to plot the terms using Excel. All right, so let's say, for instance, we wanted to figure out the first term in the sequence. So I would just find a1, which is going to be minus 1 to the 1 plus 1 power. So I'm just substituting 1 in for n, and then 1 plus 2. And that would be equal to 1/3. All right, so we get negative 1 squared, which is positive 1, and 1 plus 2 is 3. The second term in the sequence, a sub 2, is going to be negative 1 to the 1 plus 2 divided by 2 plus 2. And that's going to be a negative 1/4. The third term in the sequence is going to be -1 to the 1 plus 3 divided by 3 plus 2. Now this is -1 to the 4th power, which is a +1, and then 3 plus 2 is 5, right? And then we could pretty much guess that the next term is going to be -1/6, but let's just do our due diligence by substituting 4 back in. So a sub 4 is going to be -1 to the 1 plus 4 divided by 4 plus 2, which is going to be -1 to the 5th, or -1, and then 6. Okay, so these are going to be our first 4 terms in the sequence. Now, let me show you how to plot the first 4 terms in the sequence, and using Excel is going to be a pretty easy way to do so. All right, so just open up a blank spreadsheet, okay, just like I have here, and I'm just going to make these cells a little bit larger. All right, if you've never used Excel, it's not going to be all that bad. All right, so and I'm just moving these over just so that way we can see it. So I'm going to plug in the index 1, 2, 3, and 4. And remember what our formula was. Our formula was -1 to the n plus 1 divided by n plus 2. What I'm going to do is, instead of n, I'm going to make that a1, which is going to be the first cell. So this is going to be equal to -1 raised to the quantity of a1 plus 1. All right, so whenever I want to reference n, I'm just going to plug in a1, and then I'm going to divide this by the quantity of a1 plus 2. Right? And that should give us a -1/3, all right, or 1/3, excuse me, which it does. All right, so remember we got +1/3. And then check this out. If you just take this little box down here and drag it, it's going to give us the other terms in the sequence. All right. Now, what I'm going to do at this point is I'm going to plot these. All right. So this is just a way to actually get the terms. All right. But we already did that by hand. All right. We got the exact values, not the approximations. To be able to plot them, I'm going to highlight all of these. Okay. So just basically click in the first cell, hold on your mouse, and just highlight all of them. Go to Insert. Okay. And then there's this little scatter right here under the Insert tab. So I'm just going to go ahead and click on that, and then just highlight the scatter plot. All right. And this is what the plot would look like, at least for the first 4 terms. All right. We could change the title, and we could add in labels if we wanted to. So if I wanted to just title this, I would just say maybe something like a sub n equals -1 raised to the n plus 1 divided by n plus 2. Okay, just to give it a title. And then if I wanted to, I could go ahead and click on this plus button. I could click on the axis titles, and this could just be like our x-axis, or in this case, n. And this would be a sub n, which is going to be our sequence. All right, so, and when we do this later, all right, in the next video, we're going to do a lot more than just 4 observations, or the first 4 elements of the sequence for this. All right, so so now you know how to go ahead and find the terms of a sequence by hand. All right, just substitute the value in like a function. So this is really like a pre-calculus problem. And then over here, you could just use Excel to be able to figure out what it looks like geometrically. Notice that we don't connect the dots in one of these sorts of sequence plots. Okay. All right. So in the next video, we're going to take a look at other ways to be able to find the values of our sequences.